Welcome back, everyone, to Momentum and Impulse. Today we're going to be doing problems involving explosions. So we have a 1 kilogram firecracker at rest. So I'll draw a little firecracker here. So at rest, splits into two pieces. Piece number 1 is 0.25 kilograms. Piece number 2 moves with the velocity of 12 meters per second to the right. All right, so this one's going 12 meters per second. And this one, it has a mass of 0.25 kilograms. So let's try to figure this out here. So even though this is an explosion problem, we're going to treat it the same thing as a collision. We know that in explosion problems, momentum initial is the same as momentum final. Actually, let's answer these questions first. What is the mass of the second piece? So if this was 0.25 kilograms and this one was 1 kilogram before, that means the second piece over here has to be 0.75 kilograms. Okay, so that's going to be 0.75 kilograms. Next part is, what is the velocity of the first piece? So we should know a same kind of thing, except this is opposite of the perfectly inelastic collision. At the beginning, there's a whole stick of dynamite, and there's a velocity of 0. Or maybe I'm just going to put velocity. I'm just going to put velocity initial. And then it splits into two. We have M1, V1, and then the other piece that splits, M2, V2. So at the beginning, we have a mass of 1 kilogram stick of dynamite. But it's not moving. It's at rest, 0. Okay, at rest. And then it splits. One piece is 0.25. We don't know how fast that goes. We're looking for that. The other piece we know is 0.75, and the velocity is 12 meters per second. So now let's find what the velocity of the first one is. 0.75 times 12 divided by 0.25. And then we get that this one is 36 meters per second to the left. Negative. Okay. All right. What is the initial and final momentum? Well, we should know the initial momentum of this is going to be 0 because it's not moving. And we see that here. It is 0. And the final momentum over here, they are both moving, but in opposite directions. And the final momentum is again 0. So they do cancel out with each other in 0. So initial momentum is 0. Final momentum is 0. Okay. All right. Let's move on. We have a 57 kilogram person is on top of a 2.1 kilogram skateboard and holds a 1.7 kilogram bowling ball. Initially, the skateboard and person are at rest. The person now throws the brick 18 meters per second to the east. So the brick, it's a bowling ball. Okay, gotta change that. Which direction will the skateboard move? So we should know if this bowling ball gets thrown to the right, the skateboard is going to be moving to the left. So it's going to be moving to the left. Next question is, with what velocity does the person recoil? So I know this doesn't seem like an explosion problem, but it is because pieces are breaking apart from each other. Or pieces or objects, human and an object. Anyway, things are breaking apart. So let's just kind of look at this. What we have is we have a mass. We have the person, the bowling ball, and the skateboard. And the velocity before it explodes or before pieces break out. And then afterwards, we have other things that break out. We have the mass of the skateboard and the person times the velocity of the skateboard and the person plus the mass of the bowling ball and the velocity of the bowling ball. Okay? So let's figure all this out. Mass of the skateboard and the person and the bowling ball, they're all connected. But at the very beginning, they're all not moving. They're at 0. They're at rest. And then later on, the mass of the skateboard and the person, that's going to be 57 plus 2.1. So that's going to be equal to 59.1 plus the velocity of the skateboard and person, which we don't know. We're looking for that. And then the mass of the bowling ball has a mass of 1.7, and it moves with a velocity of 18 meters per second. So now let's find the velocity of the person. Okay? Do a little bit of math. 1.7 times 18. And divide that by 59.1, and we should get negative 5.52 meters per second. Okay, hopefully that made sense. Moving on. Okay, so we have a 3.5 kilogram cannon on wheels. It's loaded with a 0.0527 kilogram ball. The cannonball initially moving forward with a speed of 1.27 meters per second. The cannon is ignited and launches a 0.0527 kilogram ball forward with a speed of 75 meters per second. Determine the post-explosion velocity of the cannon. Okay, so we want to know how fast this cannon is moving after the explosion. So again, similar kind of thing. We're going to look at the momentum at the beginning and the momentum at the end. At the beginning, we have all of this mass combined that's moving together with a certain initial velocity. Then after the explosion, we have the mass of the cannon on the wheel moving with a certain velocity, which we're looking for, plus the mass of the bowling ball, or not the bowling, the cannonball, moving with a certain velocity of the bowling ball. So let's figure this out. The mass of all this is going to be 3.5 plus 0.527. So it's going to be 3.5527. And at the very beginning, they're moving with the speed of 1.27 meters per second. Then afterwards, we have the mass of the cannon, which is going to be 3.5. And then with the velocity, which we don't know, plus the mass of the bowling ball, which is 0.0527. And this is moving with the speed of 75 meters per second. So now let's do some algebra. 3.5527 times 1.27 minus 0.0527 times 75 and divided by 3.5. And now we see that the velocity of this cannon is 0.16 meters per second. So we see that even though this recoils, it only goes slower. It's still moving to the right, but it's going at a slower rate of 0.16 meters per second. Okay, moving on. All right, so we have a 2.2 kilogram fire rocket, travels 50 meters in 4.2 seconds, and then it explodes and breaks into 3 pieces. The first piece is 1.2 kilograms and travels west at 7 meters per second. The second piece is 0.7 kilograms and travels east at 22 meters per second. What is the mass of the third piece? So what we should know is if it's originally 2.2 kilograms, this all needs to equal 2.2 kilograms, the conservation mass. So we have 1.2, 0.7, so that's 1.7. So this should be 0.3 kilograms. Now this third question is, what is the velocity of the third piece? So similar to how we did the other ones, but it's going to be a little bit different. Let's find what the velocity is before it blows up. So we know it goes 50 meters in 4.2 seconds. So I'm just going to do 50 divided by 4.2 and see that this is 11.9 meters per second. So I know this rocket that has a mass of 2.2 kilograms is going 11.9 meters per second before it blows up. And then the one piece, the 1.2 kilogram piece after it blows up, is going negative 7 meters per second. The 0.7 kilogram piece is going 22 meters per second. And then we're looking for the last mass. That one we know has a mass of 0.3, but we don't know what the velocity is. So we're looking for that velocity. So let's do some math. 2.2 times 11.9. Then we're going to do plus 1.2 times 7 minus 0.7 times 22. Divide that by 0.3. And we see the velocity is going 63.93 meters per second. Very fast. Okay. Okay, hope that all made sense. All right, let's look at this conceptual question. A spring is compressed between 2 blocks with unequal masses M1 and M2, held together by a spring as shown above. The objects are initially at rest on a horizontal surface, no friction. The spring is then cut. Which block will move faster after this cut? So when we're looking at this problem, we should know that the momentum is conserved. The momentum before it's cut and after it's cut or after the explosion is the same. So at the very beginning, it's at rest, so it's 0. And at the very end, it should still be 0. So when this gets cut, this is going to move to the left, this is going to move to the right. However, we should know that this velocity of the first one is going to move faster than this one. Because if they're going to have the same momentum but in opposite directions, since this has a lot more mass, M2, this one has to be a smaller velocity. Okay? So which one's going to move faster? M1 is going to move faster because they need to have the same momentum in opposite directions. And since this has less mass, it has to have a bigger velocity. Okay? All right, last question. This one is pretty difficult, so hold on to your seats as we try to figure this one out. So we have a 3 kilogram fire rocket is launched vertically into the night sky with an initial speed of 44.2 meters per second. The rocket explodes and breaks into 2 pieces 2.5 seconds later. The first piece has a mass of 1.9 kilograms and travels 22 meters per second at 110 degrees from the point of explosion. What is the mass of the second piece? Okay, so that part's kind of easy. So if they had 3 kilograms at the beginning and this one's 1.9 kilograms, that means this one is going to be 1.1 kilograms. Okay, conservation of math, not too bad. Okay, but next one, what is the velocity of the second piece after the explosion? So what we first need to do is we need to find right before this explodes, we need to find what the speed is before it explodes. So what we should know. This firecracker launches with a speed of 44.2 meters per second. It experiences an acceleration of gravity of negative 10 meters per second squared. It's in the air for 2.5 seconds before it explodes. So let's find what the final velocity is right before it explodes. V final is equal to V initial plus AT. V initial is 44.2. Acceleration negative 10. Time is 2.5. So the velocity right before it explodes is equal to 19.2 meters per second. So that's how fast it was going right before it exploded. Now, for this one that's getting shot to the left, the first or second piece. So this is going 22 meters per second. Okay. This angle here, if that's 110 degrees, that means this angle here is equal to 70 degrees. Let's find the Vx and Vy of this one. So I'm going to do 22 times cosine of 70. And that gives me Vx. So that's going to be 7.52 meters per second. And then I'm going to do 22 times sine of 70. And that's going to give me 20.67. So that's how fast it's going in the y direction. This 1.9 kilogram piece. Okay. So now let's find everything here. We should know momentum initial in the x is equal to momentum final in the x. So before this explodes, we should know this rocket was going straight up. So that means we have this 3 kilogram rocket going straight up. So there's no velocity in the x, so this is just 0. After it explodes, this 1.9 kilogram one is going 7.52 meters per second to the left, so negative 7.52. The other piece that has a mass of 1.11 kilograms, we don't know what the velocity is. So let's try to find that velocity. I'm going to do 1.9 times 7.52 divided by 1.11, and we get 12.87 meters per second. So we know this 1.1 kilogram piece, in the x direction, it's going to be going 12.87 meters per second. Now let's do momentum initial in the y, which is equal to momentum final in the y. So we know this 3 kilogram piece. We know right before it explodes with the speed of 19.2 meters per second. So 19.2. And now we know the first piece, which has a mass of 1.9, is going 20.67 meters per second. And then the second piece, which has a mass of 1.11, we're trying to find what that velocity is in the y direction. So let's do a little bit of math. 3 times 19.2 minus 1.9 times 20.67. Divide that by 1.11, and we see this is 16.57 meters per second. So what we see is this, the second piece in the y direction, it's going 16.57 meters per second. So what's the velocity of the second piece after? Well, we know in the x direction, it's going 12.87. In the y direction, it's going 16.57. And now we can find what the combined velocity is by doing Pythagorean theorem. So 12.87 squared plus 16.57 squared, square root of that. We get a velocity of 20.98 meters per second. And let's find this angle. Tan inverse opposite 16.57, divided by adjacent 12.87. And let's see what angle we get. Tan inverse 16.57 divided by 12.87. And we get 52.16 degrees at 52.16 degrees. Okay. All right, guys. Thanks for watching. Next time, we're going to be talking about elastic collision.